So another example, now so far what we looked at are the examples of data analysis, and there what we are most interested in is looking at the data that is already available to to find out what is currently happening, right? We were not trying to see what would happen in the future. With machine learning, what we can try and do is we can start asking questions about future, like forecasting. We can ask what can happen with if this is the data. That's what we are trying to answer. So one example here, this is a famous data set of iris flower, where you have uh, different properties of the flower, like sepal length, petal length, etc., and the variety of that flower, the name. If we train the data on a particular subset, if we let's say if we have like 700 rows of this data, if we give the computer 500 rows and ask it to learn the properties, sepal length, sepal width, petal length, petal width, use those to learn and tell what name that flower is, then later on after the model is trained, if you give it a value for sepal length, sepal width, petal length, and petal width, it will tell you what is the name of that flower, and with certain level of accuracy. So what this is, what we have here is a very powerful tool that will give you information about a new data point based on a trained model. And this can take few minutes, it can take few hours, or it can take months, depending on how complex the data is and how complex the model is that is being trained. So lots of interesting stuff in machine learning. Now if we go one level further in deep learning, it can do even more complicated tasks, as we see here. For example, on the left hand side, these are the images I took for a motor vehicle or car, and uh, tried to train the computer or the AI to detect bolts in the images. And here we can see that these are the images of the engine bay. Here are the rear wheel. You have the uh, 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 motor pulleys, and then all other images. So you have these images, you give these images to the computer and then train the model. After a few hours it says, hey, the model is ready, I know, I have all the weights. So weights as in, it'll create some sort of equation which will, if we input new values to it, it'll predict the output. And so once it is available, if we now give the computer a new set of images that have these bolts in it, it'll automatically find those bolts for you and tag them in the image. For example, here we see that in this image it was able to successfully identify the bolts in the engine bay. Here it was able to identify bolts in the near the rear wheel. Not only that, outside of machine, now the AI or this model was able to identify the bolts that had nothing to do with a car. For example, these are the bolts on in an image of a railway track. These are the bolts on in an image of a bridge. And so you see that deep learning then becomes a very powerful tool to do such complicated tasks. And beyond this, if you look on the net now, it can do even more amazing things, such as from text it can create maybe a picture of a hexagonal bolt, or it could create a video of a person putting this hexagonal bolt on a railway track, right? It can do that. So deep learning then is sort of the highly specialized area of AI where uh, uh, where lots of interesting things are happening right now. And if you are entering this field of data science, that could be one of the things you may want to get start walking towards. So how would one get started?